Well, good morning. This is Mathman here. In my last video, I was taking the derivative of the arctan of x, and I made a mistake. I didn't notice it until after I published the video, and that's a problem when you do these things alone and you don't have anybody there to correct you. It's easy to make a mistake, and I made a mistake in, of all things, the Pythagorean theorem. So I made that correction. I also tried out a new technology for me in the process. So let's get to it. So in the video, we had theta equals the arctan of x, which means that tangent theta equals x. So what we do is we draw the right triangle and this was theta, and this was x, and that's 1. And when I made a mistake was right here. I had 1 minus x squared when it should have been 1 plus x squared, because we have a squared plus b squared equals c squared, where a is 1 and b equals x. So that's the mistake I made. So when we look into the process of finding the derivative of the arctan, we take a look at, again, we got x equals tangent theta, which is equal to the cosine, or the sine, of theta times the 1 over cosine of theta. And then when you go d x d theta, we have cosine theta, because we take the derivative of the sine function first. So we have cosine theta over cosine theta and minus sine theta times cosine minus 2 theta times minus sine theta. And that's equal to 1 plus the tangent squared of theta. Now, if we remembered our trigonometric functions where we have the identities, sine squared theta plus cosine squared theta. Whoops. It kind of blew up on me. Theta equals 1. And we divide that by cosine squared theta. We have our identity. We have tangent squared theta plus 1 equals secant squared theta. But secant theta is just 1 over the cosine of theta. And that's equal to the square root of 1 plus x squared. So this is equal to secant squared theta, which is equal to 1 plus x squared. Now, if we take d theta dx, we have d theta dx equals d dx of arctan of theta, and that's equal to 1 over 1 plus x squared. My problem is I had that denominator I had as 1 minus x squared. So I was wrong. I made a mistake. So we don't want to have that out there. We want to make that correction. So this is our result, and we want to note that correction in this corrective video. And this is the first time that I've tried using this pairing of paint using, Astrolab to draw on. I happen to have an old Apple Pencil, and it seems to work, although I wish the quality of the lines was a little smoother. I'm not the greatest with penmanship, but I'm not that bad either. But it's certainly legible enough. So I did make that correction, and I'm going to post it. So, and then we're going to take a look. I did get my new erasers. I mean my dry pens, my new dry ink pens. And we're going to do the rest of the inverse trigonometric functions. We did cosine, inverse cosine, we did inverse sine, and now inverse tangent, and I corrected my mistake. You probably noticed the mistake. It was the last piece of the last video, and I made that mistake right at this point right here. So it's easy to do, and I was a little tired because it was getting on evening time, and I wasn't fully brain functional. So anyway, this is Math Man wishing you well, and my correction is duly noted. So I wish you all well, and until next time.